make it explicit, we'll be talking about patterns of multi-cluster networking, projects, and some suggested guidelines. Okay, so this is the agenda. Quick reminder of the problem statement, solution patterns, some relevant projects and APIs, some recommendations, and if you have time, a quick demo. This is a little bit about myself. I am at Red Hat, and I've been doing cloud and networking stuff for a while. Okay, so the scope of this talk is we are talking about the networking aspects of multi-cluster. There's also many other non-networking aspects. We won't be getting into that today. Even the networking aspects are huge, so hopefully we'll have enough time to cover at least some of those. But these are just for your information, some links on the other aspects of multi-cluster that you would probably want to think about in addition to networking. This thing is playing on its own. It's just it's the slides are.
Let them know. I guess just try to.
Okay.
Help it
I'll yeah. Okay. So okay. Sorry. So use cases. So I'm guessing that most of you are familiar with the use case for why would we do multi-cluster at all. But just as a quick reminder, the use cases are mostly around having HA for your applications, disaster recovery. You can't have all your applications running in one cluster or in one location. You can make bigger clusters, but at some point you got to have multiple clusters, and you probably don't want to have them in the same region. So multi-cluster is inevitable at some point. I have to keep going back here. And you also get improved performance if you've got to serve clients from different geographies. There's data gravity and compliance. There's plenty of reasons why you have to do multi-cluster. So you might as well plan for it if you aren't doing it already, which I'm guessing many of you already are. But what we'll try to show is that there are these cost-benefit trade-offs. There's a suite of solutions, and some of them are probably more complex than what you might need. So you've got to sort of understand what is the level of functionality to complexity trade-off that's suitable for my organization's needs, and that's really the key thing. Otherwise, there's lots of things that you could either over-engineer or under-engineer, and hopefully we'll try to help with that. Okay. It's running on its own. So let's start with the architecture patterns. There's a lot of patterns here. This is just to illustrate some of these. I've got some slides with a lot of content. I won't be going to all of those, but hopefully you'll get a chance to look through these later. I'll touch on some of the points from these slides. So, there's north-south networking across clusters, right? We're not talking about north-south into a single cluster, things like ingress and node port. We're talking about cross clusters. There's east-west cross-cluster networking, more than just internal cluster, north, east-west networking. There's all these other things, single mesh, multi-mesh, federated meshes, and various operational aspects. So these are the patterns that you would take into consideration when deciding on the right set of solutions, right? And we'll talk about some of these in today's talk. So to give a visual feel for some of these patterns which we just talked about, so here's sort of a conceptual picture of generic multi-cluster topology where there's 4 clusters, which I'm going to have to keep moving this back here. It just keeps running. Different projects have different views on whether you're combining clusters or you're combining a virtual mesh topology on top of clusters that aren't actually coupled together. For now, just look at it logically. So there's this north-south multi-cluster, which in this case is shown using this ingress gateway, which is actually a multi-cluster gateway, right? So that is the pattern we need to think about when deciding the north-south networking solution. And we go back. Then there is this thing about single network versus multi-network. So in this case, clusters 1 and 2. Is there a way I can pause this because it keeps running?
So what they said is if you click it more than once, it will take a moment to catch up, and then it will look like it's advancing on its own. So just give it a second or two. I wish I knew what to say. Can you turn the remote? I will let him know to come in here to help.
All good, all good. So yeah, so there's the north-south pattern. So in this case, you've got 4 clusters, and you've got the north-south pattern, which you need to think about. Then there is the east-west pattern. The network, so here cluster 1 and cluster 2 are on the same network, which essentially means that the pods can directly reach each other between cluster 1 and cluster 2. They have unique IPs and there's routing. So you don't need to NAT, you don't need any gateways to go between 1 and 2. But you do need a gateway to go between cluster 1 and 2 pods or cluster 3 and 4 pods. That's why you have that thing called an east-west gateway over there. So that's needed when you have when you want to connect pods across these networks. So that's the pattern about the single network versus multi-network, and you need to decide, or you might have a constraint on how you want to use single network versus multi-network.
Just hold off advancing for just a moment. He was able to get the slides.
Mhm.
Now he's going to switch them out. So just give it a second.
Okay.
But you can continue.
Okay. So we go to the slides. No, there's no space there. Yes.
Maybe just pretend they're not there for now. And
So while we are waiting for that, I mean, how many of you might have deployed a multi-cluster Kubernetes or even non-Kubernetes networking solution? So it looks like about 30-odd% of you, which is a good number, which is great. And I think that mainly speaks to the maturity of Kubernetes, because by now you've had so many clusters deployed, you have to do something with multi-cluster Kubernetes. You can't avoid it. And hopefully the rest of you are either actively thinking about it or just wanting to know when you should be going in there. And I think the key point here is that there's a lot of projects, and it's always going to be a cost-benefit trade-off. You don't want to get overly complex unnecessarily in the beginning. You want to kind of take it step by step, and we'll illustrate some of the possible phases in this call. Okay, he doesn't have the video, but we'll see. We'll keep going. Can I go now? All right, let's keep going. So these are the patterns we talked about, right? So this is sort of the logical view of the patterns. Now let's talk about a couple of those. Let's start with north-south networking, and in particular north-south load balancing. So here we've got 2 clusters, clusters 1 and 2. And the pattern we are doing here is we're going to fully duplicate the applications between the clusters, right? So all the traffic here across is going to be north-south in and out of the clusters. There is nothing going sideways between one cluster and another, right? And so in this pattern, you got to think about the different ways you can do this north-south load balancing across clusters, right? Again, we're not talking about intra-cluster load balancing. So one popular way to do that is using DNS-based techniques. And there's about 4 patterns we've identified, and they're listed in the next slide. But let's talk about this one right here. So here the application is completely duplicated in 2 clusters. In this case, it has 3 microservices, RGB, and you can see that it's completely duplicated in all those clusters. And you can use one of a few different projects out there that sort of do DNS-based global load balancing. One of the CNC projects in that space is called K8GB, and there's a few others as well. So let's use this K8GB style approach for this particular description, right? So there are these controllers, GC1 and GC2, global load balancing controller, which are communicating with an external DNS provider, perhaps Route 53, and having their particular URL getting delegated so that the GC1 and the GC2 controllers themselves become the authoritative DNS resolvers for those domains. So what happens is that when the client goes to DNS and says, I want to go to foo.com, it actually gets served by either GC1 or GC2, which are actually communicating within themselves. And they are deciding, based on the health of the microservices in these clusters, okay, we are going to load balance this client request to, this DNS request to GC1, and so that particular client starts getting served by this cluster. So this is a relatively simple way to get multi-cluster deployment going using the north-south load balancing pattern. Again, remember here we have designed it such that applications do not need to talk cross cluster. They always go north to south or south to north. So we talked about the 4 patterns, and I'm not going to go through this. You can look at this later in your spare time. So they are essentially, you can always use an external load balancer appliance, but that implies that that appliance is in the data path, so you have to kind of scale it up because it's actually seeing all the traffic. You can have the second pattern, which is DNS-based global load balancing, where you don't have to actually have an appliance in the data path. You're simply distributing different DNS mappings to different clients, and the network is doing the actual data path. So it's more scalable that way. The challenge, though, is that, as I'm sure most of you know, hosts tend to cache DNS resolutions. They have TTLs, which are usually quite long. Sometimes many host stacks don't even actually follow the TTL. So there could be, even though you would, in this case, set a TTL fairly low, like a few seconds maybe potentially, you could have failover delays in this case. But you do not have any data path appliance bottleneck. So I've got some sample projects here as well in the middle column. The third pattern is to use an Anycast load balancer service from a public cloud. So these are services like AWS Global Accelerator and some of the GCP and Cloudflare services. And these are a little bit expensive. They're really meant for very large global enterprise distributions, but you can get some really high performance benefits from using those. They are expensive and they are on a per IP basis. So you're not actually load balancing individual URLs or FQDNs. You are literally load balancing IPs, and once you switch over from one location to the other, every URL, every FQDN listening on that IP is effectively at the new location. But it is actually what you would want to do for a very high-end deployment. And then finally, you can do your own custom BGP-based Anycast. You can literally use a BGP-based CNI or something like MetalLB, advertise the same virtual IP from multiple clusters, and actually do this Anycast style on your own automation. You will need to have a BGP-based data center, and you'll need to know a little bit about BGP-based design with how it does the load balancing and so on, but you can do your own. So these are a few different approaches. A few years ago, we had a blog which sort of talked about some of these. This is another representation of sort of the cloud-based load balancer. Again, hopefully you can see that this virtual IP 200.1.2.10 is being advertised from different locations, and this is the kind of thing you want to do at a very large scale, sort of if you're building your own Google, that kind of thing. Okay, so the other pattern, key pattern, is east-west networking, right? Which, as shown in this picture, is when services are actually split across clusters. Earlier we were talking about services being duplicated. Now we are not talking about duplication. There may be duplication, but here, a particular service here, the green service has 2 replicas in cluster 1 and 1 replica in cluster 2. Blue service has 3 replicas in cluster 1 and 1 in cluster 2. So that means if B4 goes down, then G3 needs to be able to go cross-cluster in order to access the blue service. Here again, the basic pattern would be to start with single network, which means that the pods can directly talk across, right, as shown here. Which means that the pods, you have to be careful with the pod siders, the host siders. They're all in the same routing domain, essentially. Also, many of these projects require you to observe namespace sameness, which means that these kinds of services, you have to have the same replicas in the same exact namespaces in all the clusters, because all your Kubernetes RBAC and all of that is sort of scoped by your namespace, and you have to be consistent. There might be some rare cases where that's a constraint, but in most cases you should have a flexible namespace management system in your enterprise that you can do this kind of thing, and hopefully in a self-service manner. In any case, assuming you can do that and you have this single network model, this is the pattern here, right? The next pattern is east-west multi-cluster, but with multi-network, right? Here, you can see that these pods are in network 1, and these pods here in the cluster 2 are in network 2, right? So they may actually have overlapping values. They may typically be RFC 1918, like private addresses and so on. So you can't really directly discover a network. So you will use these gateways. Different projects use slightly different gateways, but fundamentally they're doing the same kinds of things. They're essentially natting. Some of these projects require you to NAT on both the source gateway and the destination gateway. Some others are, and depending on how you do your hosts, you can, so for example, the blue line here, one of the projects that we're going to talk about, when you're going across these networks, G3 will have to go through a gateway both at the source cluster and at the destination cluster. Whereas the red line here shows that the pod G3 is able to go directly out, possibly from the host path, but it still needs to go to the gateway at the destination cluster. So when you're looking at these projects, think about exactly knowing how the data path works, so you know the implications for latency and also sort of how to scale that gateway, right? You don't want the gateway to become a bottleneck. In some of these projects, the gateway can actually scale out with the number of nodes. In some of the projects, you always have a primary gateway and all the traffic has to go through that, which means that becomes a bottleneck. So, but this is a pattern that you want to think about when you're doing multi-network. Okay, so this is a busy slide, which obviously I won't go through right now, but you can take your time to go through it. And this shows 4 types of solutions that are frequently used to do these patterns that we just talked about, right? The first category is what we're calling CNI plus, right? These are Kubernetes CNIs which kind of do more than just CNI, right? So things like Cilium, cluster mesh, and sort of Cilium mesh technologies fall into that bucket. Then there are the service meshes, right? Things like Istio, Linkerd, and so on. Then there's implementations of multi-cluster Kubernetes APIs, right? Projects like Submariner. And then finally, there's virtual application networking, right? Example being Scupper. These are more like over-the-top networking. They are not so tied to the Kubernetes infrastructure itself. But these are all different four ways you can do these patterns we just talked about, right? I will just highlight 1 or 2 points here. You can see that all of them support sort of single network, but when it gets to multi-network, there's some differences. Many of them require some level of elevated privileges because you're doing some sort of low networking configuration, except when you've got a product that is completely in user space, like Scupper over there. Some of them have more seamless network policy between single cluster mode and multi-cluster mode, and seamless multi-cluster services, examples being Cilium and even Istio. With others, you have to have a completely different policy system, independent of Kubernetes style policies. So keep these in mind when selecting your patterns and implementations. I'm going to keep going here. So we talked about earlier that one of the issues with North-South DNS-based solutions is sort of that inconsistent failover and so on. So now you can start combining these patterns, right? So here is a combination of North-South and East-West, right? So you're saying, okay, I wanted to be really simple. I wanted to originally have only North-South, but I'm having all these clients that are inconsistent in their use of the DNS TTL and so on. So I'm going to augment it by saying that I'm going to use the DNS-based global load balancer to choose to distribute my North-South traffic across clusters. But I'm also going to use an East-West so that even if you end up going to the wrong cluster where you don't have that service, you then have the ability to go across and still get served, right? So in this case, again, you're using the East-West more to augment your North-South load balancing. If your clients were fine, you could have done a much simpler solution by saying no East-West at all, because I'm just duplicating the entire application in multiple clusters. They don't need to talk cross. But here you decided that, hey, this DNS behavior is inconsistent. I want to make it more reliable. In this case, you can combine it and augment it. Okay. Now, it's also good to, so we talked about patterns, right? So let's talk a little bit more about the projects. We talked about these 4 categories of projects, right? The CNI plus, the service meshes. 5 minutes? Okay, so I will actually then skip through some stuff here. I've got content here which you can take a look later, which sort of allows you to appreciate how these APIs are evolving and what are some key factors um, in which they slightly interpret things differently. For example, in service meshes and in particular ones like Istio, the service is implicitly multi-cluster, right? You can put, as an example here, a gateway route and the backend is a service, and it doesn't matter whether that's a cluster with backends on a single service or multiple clusters. So you can very seamlessly move. You can't do this with regular Kubernetes, right? So there you have these things like service exports and imports, and you have to have different deployment manifests knowing whether you're going into single or multi-cluster. Projects like Cilium do something in between. They have the same resource, but you have to annotate it to differentiate. So this, again, a bit of an eye chart, but I think it'll be useful once you get time to look at it to see what's really going on. And you'll realize that the gateway API in Kubernetes is sort of picking up a lot of the service mesh and multi-cluster type functionalities. And that's why many of these projects like Istio are also supporting gateway API, and gateway API itself originally started as sort of an Ingress v2 API. It was just for north-south, but over time it has added the mesh mode, right, which is the Gamma project that you might have heard about. It has added some amount of multi-cluster support. You can put service imports as backends. So I think from the Kubernetes native space, Gateway API will continue to sort of try to be a union of both the gateway functionality as well as mesh functionality. But I don't think these are going to converge immediately. For a while, these projects are going to have their own APIs, and they will try to some extent, provide. They are providers for the other APIs as well, but they will continue to have additional functionality on their own APIs, which I think you want to follow to see what is the sort of future path of evolution of these APIs. This was again going to be one example of how the gateway API differentiates between gateway mode and mesh mode. I'll leave that to you to look at later. This is an example of how Cilium sort of transparently uses annotations and tries to make things look very much like a Kubernetes API. Okay, so let's try to wrap up with guidelines and recommendations. We've got a couple of minutes here, maybe? A minute? 2 minutes, okay. So final set of recommendations is do start with a multi-cluster design. It is inevitable, but start very simple. No need to jump ahead. You can think ahead. You don't need to execute ahead, right? So there's this comment by Solomon Hikes, which is no is temporary. You can always say no complexity initially. You can always change that later. But once you allow a complexity, it's hard to get it out. So think about that. Okay. So some rules of thumbs are prioritize the north-south multi-cluster. Many things you can get done just by simply having separate independent clusters, no coupling between them, but just have north-south load balancing, right? You're getting the benefits, and you're not having cross-cluster dependencies. You don't have one cluster has to have the kube config of the other cluster in order to watch. That you have to start talking about lots of credential management and account management in that case, right? If you do need east-west cluster, which there are obviously plenty of cases, prioritize the single network mode, okay? Try to stick with single network mode if you can. It's better for some things don't even work, like stateful workloads cannot work if you have multi-network. You have to have single network. If you're having issues with IP addresses, leverage VPCs and leverage IPv6. I think this is a good reason to actually go more IPv6 so that you can retain in single network and flat network mode. Yes, there are cases where you will need the full-featured multi-cluster solutions, and the tools do exist, and they're getting better all the time. And here I have sort of a different way of having 3 levels of multi-cluster design, right? Level 1 is sort of minimize your inter-cluster dependency, just do north-south load balancing, observe namespace sameness, and don't do any east-west. Level 2 is have some basic east-west, prefer having single network. If you're running out of addresses, definitely consider IPv6 and maybe do some simple multi-mesh to either augment your north-south or for certain use cases you should. And then if you are an advanced user, then yes, you do want to look at level 3, which includes multi-network, multi-organization, where you can actually use projects like Spire to actually have multiple trust domains for your certification. And there's a lot of implications for high-scale design, which don't matter when you're doing 2 or 5 clusters in a multi-cluster versus when you're doing 200 or 500 clusters. There's a whole new ballgame in terms of how you're managing your kube configs and so on. And like for example, there's this project called KV Store Mesh, which is used to increase Cilium's scale when you're going to that scale. So think about these levels, and not all of these fall into these levels. Projects like Scupper, because they're in user space, they don't even exactly fall into that. So that's another option when you want to do sort of a user space solution, and that actually works very well in many cases. Okay, I was going to do a demo in which I was going to show that if you're doing just the north-south load balancing and you want to keep it simple, you could still have some reliability issues, right? So we talked about the DNS cache issue and so on, right? Another issue is that all of these. Okay. Okay, so we're done. So we had a bit of a delay at the start, but you've got some material here to look over, and feel free to contact me, and good luck with your multi-cluster deployments.